We can get more rules. We've got these specific rules. If you sum from I equals 1 to n some constant, of course that's just repeated addition of the same number, that's multiplication, c times n, and we found that the sum of the first n integers is n times n plus 1 over 2. Turns out there's also a formula for the sum of the first n squares. So it takes a little experimentation and then a clever proof technique called induction to show that this is true, but this sum is n times n plus 1 times 2n plus 1 all over 6. You can check that it works. Let's say I want to find the sum of the first 4 squares. Now, according to this formula, n is 4, so we would have 4 times 5 times 2 times 4 is 8 plus 1 makes 9 over 6. And let's see, we could reduce here a little bit because 3 goes into 9 3 times and in here twice, and 2 goes in here once and into 4 twice, so we have 2 times 5 times 3, that would be 30. Or we can verify that that actually works by expanding this sum. This sum is actually 1 squared, that's 1, plus 2 squared, that's 4, plus 3 squared, that's 9, plus 4 squared, that's 16. And of course 9 and 16 is 25, and there's another 5, so yeah, that sum is 30. So this formula works, at least in the case of the first 4 squares. We could do another example. Suppose we need to find the sum of the squares from, let's go from 10 squared to 15 squared. Okay, so we're going to do the sum from I equals 10 to 15 of I squared. That's going to be 100 plus 121 plus and so on up to 225, right? Well, this formula doesn't quite apply because in the formula we start off with an index of 1, and this isn't starting with an index of 1. But we could pull a little trick here and say, well, let's do the sum from I equals 1 to 15 of I squared, but that's going to have some extra stuff. In particular, it has the first 9 squares in it, so let's subtract the sum of the first 9 squares. Then what's left behind will be the remaining squares from 10 squared up to 15 squared. Now, each of these can be found from our formula, which says, let's see, if you're summing up the first 15, now they start with an index of 1, right? So you can use the formula. If n is 15, you get 15 times 16, and then 2 times 15 is 30, plus 1 makes 31, all over 6, minus, if you add up the first 9 squares, you get 9 times 10, 2 times 9 is 18, plus 1 makes 19, all over 6. And now it's just a matter of arithmetic. We just have to simplify these values. Of course, they're not that bad because, say, 2 goes in here 3 times and in here 8 times, and 3 goes in there 5 times. Here, 2 goes in here 3 times and in there 5 times, and 3 goes in there 3 times. So 5 times 8 times 31 minus 3 times 5 times 19, and then we can pull out our common 5, and we have 8 times 31 minus 3 times 19. And let's see, 8 times 30 would be 240, so we have 248, because we're taking 8 times 30 and 8 times 1. And 3 times 19, that's going to be 57. Okay, and 48, take away 48 would be 200, and then we take away another 9, so we have 5 times 191. Okay, which is the same as multiplying by 10, and multiplying that by 5 is the same thing as multiplying by 10 and cutting it in half. So that's 1910 over 2, so we have 855 for that particular sum. Now the trick was all right here, right? Another formula that's handy to know is the formula for the sum of the cubes of the first 10 integers. If you take the sum from I equals 1 to n of I cubed, the formula says that that's the same thing as n times n plus 1 over 2 squared, which is kind of interesting. It's very similar to the sum of the first n integers. If you were just adding up the integers without cubing them first, then you'd have n times n plus 1 all over 2. So the difference is here in the exponent. Now technically that would be n squared times n plus 1 squared over 4, right? Because you're multiplying this number by itself. That's what the 2 does. So, for example, if you wanted to find the sum from I equals 1 1 to 20 of I cubed, then you would take n, which is 20, times n plus 1, which is 21, all over 2, and square it. And so that sum is going to be, let's see, 2 goes in there 10 times. So we have, the sum is going to be 210 squared. Okay, let's see, that's a pretty big number. 200 squared plus, I'm just multiplying this out, 200 times 10 would be 2,000 plus another 2,000 plus 100. Okay, 200 squared would be a 4 with 4 zeros behind it. So we have 44,100 is the sum of the first 20 cubes. Okay, as opposed to the sum of just the first 20 integers would only be 20 times 21 all over 2. So that would just be 210 instead.